I want to talk about compression. Compression is the idea of reducing the size of a file that you are sending over the wire or that you're going to store on your computer, on your hard drive. You're reducing the size of the file. A simple example of compression is to take the sentence, "The dog ran down the street and bit the girl in the leg." There's 55 total characters here. Now if I replace the word "the" with a % sign and replace the word "and" with a pound sign, and I rewrite this sentence, I'm going to have 45 total characters. That's about an 18% reduction in the size of the file. That's sort of what happens with compression. We're simply reducing file size. Now, generally speaking, data compression falls in two categories. Lossless, which means we do not lose any information in the compression technique, or lossy, which implies that we may lose some of the data in the compression. So again, two different kinds of categories for compression. Lossless, don't lose data. Lossy, we may lose some of the data. Let's talk about some specific examples of compression. The first one is run length encoding. It's considered lossless. Suppose we have a string of bits, 458 bits. We have a whole bunch of ones and a whole bunch of zeros and a whole bunch of ones in a row. Well, it might be easier to say that we have 253 ones, followed by 118 zeros, followed by 87 ones. It's easier to say that and to store that than it is to actually store the 458 bits. So that's run length encoding, a way to reduce the size of specific bits within a file. Another technique would be dictionary encoding. It's considered lossless, but at times could be lossy. We're all familiar with word processing programs that come with built-in dictionaries. Let's suppose that we were working with a dictionary of a word processing program and I could identify or assign an integer from 1 to 50,000. I could assign that integer to a specific word. I could assign a specific integer to a specific word for every word in that dictionary from 1 to 50,000. Well, think about this. You learned earlier in the class that storing a short 16 bits, I would have over 65,000 different possibilities. Now I only need 50,000 possibilities, so let's understand then that I could store a number from 1 to 50,000 using a maximum total of 16 bits. Okay, well, let's suppose then for each word in a file I used a specific number from 1 to 50,000 to refer to that word instead of the word itself. So if you just take any word example, let's suppose we had a word that had 6 letters in it. That one word would take 6 bytes because you can store one letter in 1 byte. 1 byte is 8 bits. So if you had a typical word that had 6 letters, it takes 6 bytes. Well, we can store that using a number, and we can store a number in 16 bits or 2 bytes. So we're reducing the size of any word in our file that can be found in that dictionary. We're reducing the file size substantially because, again, instead of using 6 bytes for a 6-letter word, I'm only going to use 2 because those 2 bytes would be referencing a specific number of a word from that dictionary. So these are just simple techniques, dictionary encoding and run length encoding. In the next video, I'm going to give you some examples of compression for some images.